Now, sometimes people will say, well, how can mistakes get made where the proper amount of thyroid hormone is not made and released? Well, let's just see this as a reasons to show how complicated this process is. So we talked about the thyroid gland producing thyroid hormone, either T3 or T4, but in order to understand how it knows what to produce and when to release in terms of that thyroid hormone, let's go back up to the top and work our way down. Because remember, the hypothalamus is going to produce thyroid-releasing hormone, TRH. And that has a positive impact on the anterior pituitary gland, aka the adenohypophysis, by getting it to then produce and release thyroid-stimulating hormone. So when the anterior pituitary gland produces TSH, that travels through the blood to the thyroid gland and instructs the thyroid gland to produce more thyroid hormone, T3 and T4. So now as the levels of T3 and T4 in the blood rise, then that tells both the anterior pituitary gland and the hypothalamus that the mission has been accomplished. So as the levels of thyroid hormone go up in the blood as they increase, then that has a negative feedback effect on the hypothalamus and the anterior pituitary gland, so they stop producing as much TRH or TSH. That should make sense because now that the mission has been accomplished and the levels of thyroid hormone in the blood have gone up, the hypothalamus says, okay, I don't need to have more made, so I will stop producing as much TRH, which then tells the anterior pituitary gland to stop producing as much TSH, and so the thyroid gland then gets told to stop producing as much thyroid hormone, and so we have this kind of homeostatic balance constantly being switched on and off depending on the levels of thyroid hormone that need to be produced at any given time. Now, the thing is, though, is that there are other things that can influence the levels of thyroid hormone as well. Somatostatin has a negative impact on the adenohypophysis, so it causes less TSH to be produced, as do increasing levels of estrogen and testosterone. They also have a negative impact on the adenohypophysis and so reduce the amount of TSH being produced. Now, again, all this assumes that these feedback mechanisms are operating in a perfectly healthy individual. But what happens if there is a problem? So, for example, if a person has hyperthyroidism, everyone says, oh, well, they've got too much T3 and T4 being produced, more than normal, so, oh, the problem must be the thyroid gland. Well, it doesn't necessarily have to be the thyroid gland. The thyroid gland simply may be following orders. And so if there's actually a tumor up in the hypothalamus, and that tumor is causing the hypothalamus to produce large amounts of TRH, then that large amount of TRH is going to tell the adenohypophysis to produce more TSH, and therefore the adenohypophysis produces more TSH, which signals the thyroid gland to produce more thyroid hormone. So simply put, maybe the thyroid gland is not the cause of the problem, but is actually following orders from both the adenohypophysis that says, hey, I too was just following orders that were sent from a hypothalamus that maybe has a tumor in it. So simply saying the person has hyperthyroidism and it must therefore have a person who has a problem with their thyroid gland itself is not really looking at the whole story. This is why they have to do a complete panel of hormones to see what the levels of TRH and TSH and thyroid hormones are. Now, in one of the labs, you are all working on the virtual rat, which they have an example of looking at the levels of TRH and TSH and thyroid hormone to figure out what would happen at different levels to cause problems along the line. So if the levels of TRH were higher than normal, and the levels of TSH were higher than normal, and the levels of thyroid hormone were higher than normal, it's probably more of an issue with the hypothalamus being kind of having a problem right at the start of the process. However, maybe the levels of TRH are normal, and the levels of TSH are very, very, very high, and the levels of TH are very, very high. Well, then at that point, it's probably not a problem with the hypothalamus. There may be a tumor with the adenohypophysis, and it's just gone kind of rogue and is producing lots of TSH on its own and is signaling the thyroid gland as well. So again, you have to look at all the different levels of the different hormones and not just say, oh, the person has hyperthyroidism or hypothyroidism and then blame it totally on the thyroid gland. The thyroid gland might be the root of the problem, but it also could be a problem with either the hypothalamus or the anterior pituitary gland, and it needs to be really kind of looked at thoroughly before any decisions are made as to what the cause and therefore what maybe potential treatments could be used to help mitigate the problem. Now, again, sometimes people will say, well, how about a goiter? How can a goiter be caused by too little or too much thyroid hormone? You know, you have hypothyroidism and hyperthyroidism, both potentially having goiter as a symptom. Well, if the person has very, very low levels of thyroid hormone being produced, then the body may say, look, we need more thyroid hormone, so it sends the resources to the thyroid gland to build itself larger. Well, if the thyroid gland says, look, the reason I can't build thyroid hormone is because I don't have enough iodine, then giving the thyroid gland more cells and having it build on and get bigger and bigger and bigger isn't going to solve the problem if the root cause is it doesn't have the raw material iodine to build more thyroid hormone. So the thyroid gland will certainly grow if it's given the resources, but that wouldn't help solve the low levels of thyroid hormone if it's caused by low levels of iodine. Now, by the way, iodine is found in seafood in large amounts because iodine is something that is found in the ocean. And so animals that live in the ocean absorb that into their body, and so when people eat those, say, shellfish, they are actually picking up some iodine. Now, in today's world, we actually have added iodine to salt. That's why it's called iodized salt, and so many table salts actually contain iodine in it. So no one needs to go out of their way normally to add more salt. No, because they're getting enough iodine probably normally in the salt that they're already consuming. Now, what about having more thyroid hormone than normal? Well, if the person has a situation where they are maybe being told by the hypothalamus to produce more thyroid hormone than normal, then if there's an issue with maybe a tumor in the hypothalamus, then more TSH would be called for, and therefore more thyroid hormone would be called for. And in order to meet that demand, the thyroid gland may have to grow much, much, much larger, not because it really, really, really needs to, but because it's being told to by incorrect information coming from a hypothalamus that has a tumor in it and is therefore producing higher than normal levels of TRH. Okay, so that kind of explains what should happen, and I again point these feedback mechanisms out to you all, going all the way back to part 1 where we were talking about homeostasis and negative and positive feedback mechanisms, and here's some good examples of how these are used kind of in action. That takes us through talking about thyroid hormone.